Hello everyone. Okay, today I will continue our online seminar with my research topic. The title I would like to present today is the personal data story. So, okay. So the main content I will present in my talk. The first, I will start with the personal data story. The details in this part, I would like to introduce what is the personal data and what is the condition of the PDS or the characteristics of the PDS. I also give the choose common example of the PDS in the real world. After that, in the second section, I focus on the three most common the other approach to employ the PDS in the spectral environment. So if you have any question, yeah, just ask me events when I present to interrupt my presentation. Okay, go more detail with the first part. What is personal data? That's the easy question, but what is personal data? Yeah, somehow I can have your student ID from this info. I can get the relevance info of yourself. That is the example of personal data. So the personal data is any information that relates to an individual or especially you can identify someone from your friend or from the big group. Yeah, that is the identifies info, also the personal data. But we can have the other way to identify the spectral user or the particular user by using the available or the data released from the user. For example, in America, they can use the name combined with birthday and the gender to identify 87% of the citizen in USA. That's the reason why we can combine the available information to the exam one is also the personal data. So the other definition of the personal data is the different speed of the information we collected together can lead to the identifications of the particular person. Some available, something like the name or surname, home address, email address in the same cluster, as you can see in my screen, and whatever you have to try to analyze. Yes, so why the personal data is very important for the user? Because depending on this info, the attacker can get more useful info for them. Maybe it behavior, the health issue of the one guy. That is the reason why the user more and more consider the privacy problem from now. So that is the definition of personal data. So what is the personal data service? We can find three different terms of personal data storage. Is the personal storage, as I mentioned, personal data service, or also personal data store. Okay, from this slide, I use the single term personal data storage or PDS. It's mentioned in the choose or remaining terms. So it's the service to let an individual store, manage, and deploy their key personal data in high secure and structured way. That is PDS. So how the system can become a PDS system support the user, depending on spectral characteristic, we can believe on the storage or not believe on the storage. So in the next slide, I will introduce four main characteristics of personal data storage. Go detail with the transparency. Yes, transparency, that easy. The user really want their information knowledge, more knowledge about the information. For example, one person want to use the Facebook. They easy to share the status or the picture for their friend or relative or whatever they want. But in somehow, maybe in some game, spectral game, maybe you know about the Angry Birds. Yeah, Angry Birds. I have a short time analyze some application to get some bad behavior of the application in Android platform. I don't know exactly in iOS, but in Android platform, the Angry Birds collect the exactly location of the user. I don't know they use this information for which kind of service, but for sure they can use this information for the advertisement purpose or the other purpose of a third party, untrusted party also. That's the reason why the user needs to know how and when data is being collected and how data is being used for the special service or the feature of the service provider. So it means that in this system, the user needs a better understanding of the overall value exchange, so what they can make truly informed choice or a skill choice and control, especially where data use or more affects them. So it means in this system, it requires design and usability must lie at the heart of the relationship between individual and the data generated by or about them. What is about them? Yeah, you hear some kinds of information about the guy, but by them, it means the data created by a special personal. For example, when you use the application or when you read some news in the website, some interaction data collected by the service provider also. I read some paper about the self-driving car. It collects the behavior of the user to prevent the traditional authentication. They don't need to use the key to open the Turing or a machine to start a car. They just use some behavior of the user and can start a car. So that is the big difference. And the organization need to engage and empower individuals more especially and efficiently, because currently all the information of the user stored in the data center or the third party, trusted third party or untrusted third party, depends on the service provider. If they use trusted third party, they need to space more fee. And it means that the user needs to space more for this requirement. And for the third party untrusted, they can reuse the information for their purpose. Okay, we need to try off the scene. In the asset, not authorization, it's higher than the authorization. In authorization, the user can control their data in general picture, their data by define the policy, maybe which kinds of service I agree to explore my data and which kind of service I did not agree or something else. That is the policy of authorization. But in each asset, the requirement in asset is maybe more. What is more? It also supports the tool, easy for the user to use as, maybe when you install the new application or install the new tool or something on your MacBook or your device, they're easy to use because you have the background in computer science. But for the normal user, how user can control their data, that is the requirement of the PDS also. So it means that enable them to either understand or readable diagram, chart, symbol, color, but everything, whatever, but not in the raw data. So that's a big gap between the normal user and the expert user. That's the reason why the user, if they want to protect spectral data, the PDS system also create some kind of tool to support the generated policy automatically, or support the user by some question, simple question for user. Yeah, which kinds of user can access of your data, which data you want easy to share, and which one a special condition to share this information or something else. And currently, in this requirement, they have a big gap between the text meaning, something user can understand, and the policy structure readable for the computer. Maybe they focus on the define the interface between the text meaning and the policy structure. The policy structure, it's a common like XML or JSON define on requirement of the test mining. After that, the user needs to train the policy. That's normal because maybe today I believe some guy to share the data, but in tomorrow I want to revoke this permission. That's the reason why the application, the PDS server, PDS system needs cover requirement to support the chain ability for the user in the policy management. How they can do that? Yeah, if they just update chain, that easy. But the main point in this problem is how can detect the conflict and redundant policy in the big policy. That is also the hard work. I read many papers about authorization. They use the combining algorithm to define the single policy from the big data policy of the user. If the user change the application, they can change do whatever they want, depending on the different combining algorithm. The decision of the user may be changed also. Okay, I can introduce three common of combining algorithm in this aspect. The first applicable is mean when the system finding one spectral map with requirements of service provider, depend on the decision, they will grant or reject the requirement or permit override or deny override in the list application. Sorry, in the list policy, they found the spectral deny or permit, they will follow in this direction to answer the service provider. In the controls, if they focus only readable, openable, or readable, that's easy. But erasable is the hard work in the control requirement of PDS system. Why? When you share easy your information with some company, yeah, if you change the policy to this company from grant to deny, that's easy. But the data when you share for the company, it's still there. It's still there for them. They can easily to use of the other purpose. That's the main point. Because yeah, I saw the reason. Because the retention of data involves both cost and risk, including being raised and measured. That's reason why the user want to delete the own data if they easy to share and they easy to delete also. So I have some info in the control to someone who want to follow in this way. I read many papers. He do something like from the original data of the user, he create a small interface or small window from the original ones, and depending on requirement of service provider, they show the small interface mapping with the whole requirement of service provider, and also give the function to enforce this information to the user, to the service provider. When they don't want to say anything else, they can they can delete this permission and the interface also. If there's someone new guy or new service provider join the user system, they also create the new small interface and follow this way. Okay, in the transfer. Okay, in the transfer, it's very, very hard, for sure. It's very, very hard. Because currently, Osmo, the system focus on the system-centric. It means all the data stored in the center, the data center. Even when they have the many strong approach to support the privacy, for example, differential privacy, anonymity, replacement, yeah, many things I cannot list here, but they have the drawbacks. They also have the drawback for the data stream. I just read the one paper focused on the differential privacy. It's unapplicable with the data stream. So that's why I mentioned it's very hard. And the main key info in the transfer of the data is mean that when the individual want to share this data, individual, not in the service provider, it means the user, he want to share this information to not on the service provider to the other one, how they can transfer on the policy to the third one. That's the main research question. Because I easy shares my fitness data to the healthcare center. That's easy for me. But in Facebook, I don't believe Facebook. I don't want to say anything about Facebook. Yes, that's the reason why I want to protect my fitness data from the Facebook. How I can do that? If the data center want to share my information to the Facebook, it means in the PDS, it also supports the transfer requirements in the in this application in this approach. So, okay, I just mentioned it example. Yeah. Okay, go to the next example. External part. In this slide, I would like to present two main most common example in the real world. First, my data of the UK government. In the my data, you can see the definition easy on the slide. I don't want to read the all information available here, but I just focus on how they can do. I said the data transformation, it look like something the user have the big data, and if the user want to use some service of the company, they just relate the monitoring to the company, and depending on this information, the company can have the all requirement of the from the user, not the original ones. That is the idea. But it has the problem in here in the laws, not in the system. The company has been complying with the laws in the way that did not rely the real potential values of that right to data. It means the user needs to wait a week later to receive a few dozen pounds or something. For the other example, smart disclosure. Smart disclosure is the product of US government, and it also quite example with my data. In this system, the user have the full control of their information, not only the personal data. They also create the small thing depend on this information they can use to receive some the good service of the service provider. Yeah, that is the two different example of the PDS from currently. Okay, I skip in here. You have any question about the first part of my presentation? Just let me know. No one, okay. Okay, I continue with the second part. Okay, in the second part approach. Okay, in the previous section, I present about definition of personal data, the PDS, and characteristic of PDS also. I will continue the approach, the three main approach from currently to fulfill all requirements of the PDS for the user and the service provider. So in this section, I just focus on the general idea, how they can use how they can use the tools or the approach to deploy the PDS on the spatial environment. And if you want to get more detail about the paper or about the idea, how they can do this, just follow the paper. I also show the paper before I go to details. Okay, just start with the OpenPDS. In the OpenPDS, it's focused on the interface, how they can answer enough the question for the service provider, not go details of the personal information. Okay, first, what did the OpenPDS allow? They support for the on user data, not only the personal ones. So it can collect, store, yeah, that's easy for the normal system, but also they give the fine-grained access by sharing anonymous answer, not the raw data. So, okay, I have the example in this point to make more deeper. Okay, the first, when I go to the supermarket and I want to check some support channel for the new customer or guess the list of product have a good price, discount or some the other reason. And I ask some application, maybe application A, and I ask them some kind of question, as I mentioned. And the application required all information about the location. It means that I don't have any choice. One, I show my location and I receive what I want. The second thing, I don't want to show anything about my location and I did not receive anything about the application. So this example is the normal for the Android platform or iOS platform also. We don't have any choice. One, accept all requirements and we can use this application. Without, we don't have any more come back from the service provider. So before go detail how they can do, just go the idea for the second paper of this group. In the first paper, they focus on the user data, and the second one, they focus on the metadata. What is the metadata? Yeah, I just to remind you, because I believe you know what is the metadata. Metadata is the data of the data. When you take the picture is the data, and some relevant info of the picture is the metadata. For example, the time you take the picture, the place you take the picture, the size of the device, with friends of the device, or many things else. The other is the metadata. It also includes the personal problem when the attacker can access all the information. So go detail first with the user data, how the OpenPDS can support the user to control the personal data. Currently, as I mentioned, the user should balance between the convenience from the service provider and the risk. It means the privacy violation. So in somehow, we have the one assistant, maybe digital assistant or something. They will answer all requirements of the service provider, something like, where I'm standing now. My digital assistant, something say, oh yeah, I'm in the office. And what is exactly office? Sorry, I cannot show the info with more detail. Just know that I'm in the office. Which office? No, I don't need to go more detail. Something like this. And depending on this information, I can guess also the convenience or the benefits of the service provider, and I can protect my personal data. That is the main idea of the OpenPDS. It looks like the filter layer between the user and the service provider. Whenever the service provider sends the request to the PDS always load the raw data from the user and review the details of the data before sending it to the service provider. Okay. So I have an example for this point. Alice, in someday, she wants to install Spotify to enjoy the music or what kind of music, what she wants. Okay, in the normal way, she needs enjoy directly and allow all the permission in the Android platform or maybe on iOS platform also. But Alice wants the protect some key information about herself. That's reason why Alice to define the PDS, and in the PDS they also create the PDS, the Spotify PDS. In the Spotify PDS, it's like the filter as I mentioned on requirements of Spotify about the Alice. The general questions, something like which kind of music or something more else, the Spotify will answer. Yeah. In this way, Alice can also listen some music from the Spotify, and she can skip some personal data of herself. Maybe music can stay with kind of music she like, contact, the list of friends, relative, the other guys, streams data of the other sensor. But you know, in the mobile include maybe more than 10 sensor, maybe accelerator, meter, or many things. Alice can take on the personal data of herself, and she can control the data resend to the Spotify before send the raw data. Okay. In the metadata, it's quite similar the structure of the open PDS, but the main information different is in the second paper focus on the metadata, and they also show the interface of shape answer. The shape answer is the name of tool to support the metadata. As you can see in the first picture is the main interface of the application, and the second thing is the report interface of this user. She or he easy to get more information about service provider, access which kinds of metadata, the times, and how many times in the per day or per month. Okay, and the data processing process is similar to the open PDF, different only from the metadata and the personal data. Okay, in the first approach, do you have any question? Okay, we go straight. The second thing, many paper use machine learning algorithm to support the user in the PDS. Many kind of support, for example, in the first idea, they support the user to answer the alarm. Yeah, when you install the new application, they always alarm something like the notification. This application can access media file or the camera, or this application can send a message to the other one, whatever. And in the first idea, he creates the automatically tool to answer these access requirements by using the user privacy preference. And the second idea, as I mentioned in the characteristics of access, the user needs some kind of access policy language, because it needs to readable for the computer. It also have the meaning for the user. That is the big gap between. And this paper try to fill this gap of the user and the service provider. Okay, go more detail with the first idea. The motivation of first idea is something like designing a PPDS that able to automatically make the privacy aware decision on third-party access request. Yeah, it means something like in the new access request come my computer or come my my mobile, I don't need to answer. Depending on my behavior or my privacy preference, they answer directly. So I have examples in this point. We have two users, 1 and 2, and one service provider. both of them want to use the service from the list of service provider, and service provider require the location info for both of them. In user one, he did not agree. And the second one, yeah, he easy to share this information to receive the benefits of service provider. So depending on the behavior of the user, they have different decision. I'm not focused on the context. I will focus on the context in the second idea. In the first one, I focus on the behavior of the user. Okay, to detect this. So this paper uses active learning to learn some privacy reference of the user, especially user, and depend on this knowledge, they will answer automatically the new requirements. So three active learning algorithm you can follow in the name is here. I also show the paper. You can read more detail. Okay, this paper allow the five-range learning of the privacy attitudes of PDS owners. First, decide privacy aware PDS able to automatically answer the service provider request. And when the new access request come, they give the granted or deny based on the knowledge get from the original database. So to do this, the author define a tuple have 5 different elements. This is either the data type is mean the service provider, and SDE the type of the service, for example, sport, healthcare, social network, whatever. These all is the requested data. Maybe it includes the personal data or not include. Yeah, depending on the service provider. After that, the purpose, whatever the purpose, maybe for your health insurance, for your training, yeah, many things. And finally, the user can receive the benefits from the service provider. Maybe they can receive the some gift for the surveys or some voucher, discount voucher, yeah, for the product of this company or service provider. Yeah, you can follow the algorithm in detail in the 4 paper in here. So finally, the model, the privacy aware PDS. As you see, we have 2 actors, data owner and data consumer. Whenever they send the request to the system, yeah, it's based on the learning, the knowledge from the previous accept request, they will answer this question directly, and they update this result to the database, and the new accept request come and answer. Yeah, in the previous time, maybe in the initial time, maybe the system needs to confirm the label, make the label with the user. The user label some question, maybe 10 or 15 accept requests. After that, this system can work automatically. Okay, goes more detail with the second idea, how they can to define the policy. For example, when I present my presentation in the meeting lab rooms, I easy to share the location. But when in the evening, when I come back to my room, I don't work anymore, and I don't want to share any info about my location where I'm staying. So how I can do that? I cannot open my laptop or write some code and create a new policy. Maybe, as I mentioned, it has some conflict or redundant because, yeah, in some special day, I work on time and I need to work later than the normal days, maybe 9 p.m. or maybe 10 p.m. Yeah, I need to open my computer again to rewrite the policy. No, it's not good for the user. That's reason why this paper try to mapping between the behavior and the context to create a different policy. So I also mentioned this. Yeah, when I work at home, yeah, oh, sorry, when I work at the office and when I rest at home, yeah, it is big difference between the context and between my decision to share the information. Okay. Yeah. So in more detail, if I standing in the context A and I move to the context B, how can I generate the new policy? Yeah, that's the easy question, but it's hard to answer. So in this paper, the first thing, they try to follow the context. The most similar context have the nearly the same decision or the same policy, and in different context, maybe the user want change much more. So how they can define is via the user privacy reference. This is the main research question of this paper. To fill this, the authors create the tuple has 5 pair elements. The first is time, location, action, and social relationship. And the privacy policy structure includes 4 things. First, the purpose. Yeah, maybe all the purpose in this one, healthcare or advertisement or whatever. And the data, the service provider want to collect from the user. Also, the time for storing. As you know, when you share some information or some general info, not personal data, you don't care how long they store this information. Yeah, because depending on service provider, not depending on you. You don't have any choice if you share your information. Okay, in this paper, they did not mention how they can verify it removed from the service provider database. Yes, but they just show something like, yeah, I deal with you. I will store it in 3 months or 4 months. After that, I will remove this. That's it. And the last one, the service provider can share this information for the other service provider, the third party, or review the information for the maybe the other purpose or something else. Yeah, they also show in the policy. It means the service provider needs to show all requirements in the one accept request. Go next with the Mincer matrix. In the Mincer matrix, he have 4 different metrics to measure the distance from the previous methods and the new one. He's mentioned choose way to measure the first time distance that easy. The notation from the time, different times is the rank from 0 to 1. That easy for get more info. And the second thing, he's reused the Wu and Palmer approach to measure the distance between the location, activity, and social from the previous contact to the new one. As you can see in the tree structure in here, in the one element, he's defined as the hierarchy tree structure. Yeah, so you can get it easy, something like actually coding or studying in indoor or outdoor, working or driving or something else. And depending on the contact info, he can measure the distance between the activity. For example, activity in the first, he cooking at home, and after that he working. He needs to measure the distance between 2 different activity by using you can see here to measure the distance in this equation, where if from the root to the parent is the nodes have the close accessor distance to the 2 different nodes, one from the previous contact, one from the new one. And this is is the length of path from the parents to their nodes. Okay, for example, in we get so cooking and driving. Yeah, they have only the root. Yeah, the only root is a mod accessor, lowest mod accessor, and the depth in here is 0. Sorry, depth in here is 0, and the distance is 2. It means that the distance value of activity is 1. 1 minus 0 is 1. Okay, it's very far. It's very different. Something they do in their home, very different with they choose some activity in our. After that, he get the distance between two different constants by using the average value of 4 value. So in here, the user also label the constant by privacy reference. After that, if they have the new reference, they will reuse the knowledge from the label database to label the new one. Okay, go to the last approach, blockchains. Why you blockchain in here? Yeah, easy to get the reason. The blockchain is very strong in transparency. In the transparency, we can easy to validate the information is true or not. That is strong blockchain characteristics. So I don't want to focus more detail in blockchain because most of you know what is blockchain, and it's also the topic of the other fellows. So I go to the details of the paper, how they can use the blockchain to support the PDS in this scenario. For example, Alice is a student. She just graduated and she wants to find a good job. She found some open position of the Mr. Smith company. So the easy way, she sent the application to Mr. Smith and wait the feedback from Mr. Smith. Okay, Mr. Smith want to require the proof of authenticity. It means that some info Alice writes on the application are true or maybe not true. How Mr. Smith can prove, how Alice can prove all information about herself is true with the Mr. Smith. In the traditional times, in traditional way, we have two ways to prove this. The first one, Alice can invite some agency, the justice agency, to prove that yes, all information about the document are true. Or maybe Mr. Smith, if he has more time to verify the information we show on her application, he can come directly to the university to ask some question about her application. That's easy way, but it's waste time for the both aspect, Alice and Mr. Smith also. In this paper, they propose the systems based on the blockchains to store the key value that can support the verification process. How they can do this? In this model, as you can see, we have only two actors. The first is the data consumer, maybe the company, or the data custodian, university, or maybe the user can choose in this system. But the picture of this paper, something like Alice held the PDS, and this PDS created from the university, and the university is the original data, the big one, the very big original, and Alice can create for only herself. Yeah, maybe some information about herself, her stories, or her grade, whatever he wants to store inside. And she wants to share some small interface to the Mr. Smith. And how she can prove that small information of her interface is true for the original one. Okay, that's the point. So before to validate the information in the application of hers, we the company needs to register in the system the first. After that, depending on the register requirement, the data custodian will create the key information and the value of this key by combining three information. First, data subjects, some kind of the rate of or the activity outline of Alice or something else, and data resource where also the ID of the custodian who create this data and whatever. Okay, after that, they store all information under the pair of key and value. The value is the hash value of all information is DS ID, it means data subject ID, DC, data custodians, and data resource. After that, they generate the symbol. It also updates on the blockchain and also send the encrypt key by using advanced encrypt standards, and send this information to the data customer. Before data customer receive this information, they need to fulfill all requirements of authentication process. After that, they can receive and compare two values. The first one, he can use the key stored in the database of the university, and the second one, he can generate the keys by using the information he available from the Alice and compare to get the difference between the two keys. Okay, so thank you very much for listening. If you want to get more information or the detail of the paper, just follow the reference in here. Okay, by the way, thank you very much. If you have any question, just let me know. I'm very happy to give reply.
Thank you very much for the very interesting presentation. I have a couple of questions I would like to ask you.
Okay.
So one is on this blockchain system that you just described. Do you remember how it is called?
Oh, sorry. Oh, where my slide? Okay, wait a minute, sorry. Okay, maybe I can stop there and we can discuss more. If someone guy wants to focus on the slide, I will show it again. So sorry about the inconvenience. Okay.
Yeah, no problem.
Okay, can you re-ask me what
yeah, do you remember the name of this blockchain system that you described?
Maybe no, because he just mentioned the model proof of concept. He just showed the model, not implement, I think.
Okay. Because it looked a little bit similar to something I had seen a long time ago. Are you aware of Hyperledger Indy?
Yeah, I know Hyperledger.
Yeah, because they have this blockchain for managing identity documents, and it seems a bit similar to this in that you have these certified documents.
Yeah. Okay. In blockchain, it's not available for privacy. I agree with you for sure. That's reason why they have to choose different term off-chain and on-chain. They can easy to share public information because the other peer or the other party can easy to see or get the information when you share on the blockchain if they join in the same system. And in the if you share online or publicly, but in some key info you want to share, you can keep it in the option. Yeah, that's one way. Maybe in previous time, not now, I chose one project to improve the privacy problem in Hyperledger. Because in privacy, it's very hard to answer it safe or not. It's very hard. So they need to use the other approach one of them I use in the previous time, that is the encryption. The process I use is zero knowledge proof. Depend on some the key information, I just show the proof of the information. Something I have this, yeah, you agree or not? Yeah, depend on you. But if I have this proof of zero knowledge proof, yeah, you should be agree, because I also show the evidence, yeah, to prove I have this.
Yeah. And I have a slightly different question instead, regarding the machine learning approaches that you described.
Yes, machine learning.
So that looks very interesting. But
okay.
One thing that I was thinking about is that in the case of, so the machine learning system has to predict what your, let's say, privacy preference would be for a particular request. And
that's good idea. Yeah, they can predict this. Okay, good.
Yeah, but have these systems been evaluated, and how much have they been evaluated? Because I'm thinking machine learning systems have a tendency to have a few errors every now and then, but an error when it comes to releasing data that should not be released can be extremely costly.
Yeah, that's an interesting question. Maybe depends on the information the user show for the machine learning machine learning algorithm. Maybe in the 4 paper I introduced in my talks, it show enough information. But in your question, maybe the user can show more information, and from this information, the machine learning can predict what they want more than what they think. That also becomes the privacy problem. That's very interesting. So currently, I think we have the one solution, something like we can have the prediction. Maybe in this information, how application can predict how much enough for the user. Maybe if I add more info in the how can I say, if I get more info about myself to the machine learning algorithm, they can get more information prediction about myself. It means that I don't need to show this information. 3 or 4 information about myself is enough. I think currently that's the first thing come my mind. Yeah.
Okay. And also another thing is in the second machine learning system you presented, where they consider the similarity or the difference between the contexts, because different contexts, of course, require, that's important, they require different privacy. So do you have more details on how they decide these hierarchies of contexts, and how do they place your activities? So do you have to tell the systems that you are driving, or that you are eating, or that you are working? How does the system know if I'm working from home? How does the system know?
Yeah, that's a good question. Yeah, you know, the author assume everything available. the author assume everything available. Yeah, when the author believe that I show the true information. For example, when I presentation, it means I presentation. It from the user side, not from the system side. System cannot detect this information. Maybe we can use data stream to detect the behavior or the activity of the user in the timestamp by using some kind of sensor as a accelerator or many the other IoT device to detect the information. But I think in the future, but currently this paper just focus on everything the user show for the system it choose. No one to validate the information true or not.
Yeah, I think that this might be a very interesting future work, because now.
Yeah, of course. I focus on the data stream to detect. I work with George. He's focused on to how can recognize the activity of user, and me, I focus on the privacy problem. How the user can protect the activities in the data stream. It's very hard in the transfer data, as I mentioned. I read many literature, but no one can give the strong approach in this field. So yeah, use your right, this interest way.
Yeah, very interesting.
Yes.
Well, thank you very much for the presentation. Also, thank you very much for your answer. I think you answered all my questions.
Okay.
So does anyone else have any more questions to ask?
Yeah. Anyone have a question?
So it appears that no one else has
he cleared everything. He cleared everything.
Yeah.
Okay.
So,
okay. Thank you, my friends. Okay. See you.
See you. Bye. Thank you very much
Bye.
for attending.
Yeah.
Thank you very much for the presentation. Bye.
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 Bye, people.